is your second video for 5-4 solving radical equations. And this brings us to example 4. This one differs from what we had before because rather than having a square root or a cube root in our problem, we actually have a fractional exponent. So if we are going to solve this, we do need to eliminate that fractional exponent. And to do that, you merely raise each side to the reciprocal exponent. So if the x squared plus 5x plus 5 is to the 5/2 power, I'm going to raise each side to the 2/5 power. Because 5/2 times 2/5 is going to be 1, so that is going to be eliminated. We're left with x squared plus 5x plus 5 equals, and 1 to the 2/5 power is 1. Now I'm going to go through and solve this. I'm going to subtract the 1 over, get everything on one side so I can factor. This is going to factor into x plus 4 and x plus 1. And so then the two solutions I get are -4 and -1. Now, just like with everything else, we do have to check those and make sure that they both work in the equation. So if I check the x equals -4, I have -4 squared plus 5 times -4 plus 5 raised to the 5/2 power. I'm going to see if that's equal to 1. So this is going to be 16 minus 20 plus 5. That gives me a positive 1, so that does check out, which means -4 is a solution. And then I need to check the x equals -1. So I have -1 squared plus 5 times -1 plus 5 to the 5/2 power, and 1 minus 5 plus 5 is also 1. So that one does check out as well. So actually for this question, both of those are solutions. So sometimes you won't get any extraneous solutions. Sometimes both of your solutions that you get just work. So this is part B of the same question. We do have, again, we have one rational exponent and one exponent that, I guess technically it is rational because 3 is 3 over 1. So we're going to solve this using a very similar method to what we had before. And I suggest when you are doing this type of question that if you're picking which exponent to raise to first, that you pick the one that is a fraction. If you have two different fractions, you can pick one fraction and then do the other fraction. But with this one, I'm going to do the 2/3 first. So raised to the 2/3 power, so that's going to eliminate this. I'm left with x plus 18 on the left. On the right, 3 times 2/3 is going to make this to the second power. So I didn't actually eliminate that exponent, but if I have x minus 2 to the second power, I can expand that, so I can actually get rid of the parentheses. So that's x squared minus 4x plus 4. Now I'm going to get everything on one side so I can factor and solve. And this is going to factor into x minus 7, x plus 2. So I get 7, and -2 is my two solutions. We need to go through and check those, just like we've been doing. So if I check the 7 plus 18 to the 3/2 power, I want to see if that's equal to 7 minus 2 cubed. Well, 7 plus 18 is 25 to the 3/2 power. I'm going to see if that's 5 to the 3rd. Well, the 2 on the bottom of the fraction means I take square root, and the square root of 25 is 5, and so they both equal 5 cubed. So that does work out. So your 7 is good. Now if I check the x equals -2, -2 plus 18 to the 3/2 power, -2 minus 2 to the 3rd power. So -2 plus 18 is going to be 16 to the 3/2 power. and I want to see if that's equal to -4 to the third power. Well, on the left, the square root of 16 is 4, and 4 cubed is 64. -4 cubed is -64. The negative and positive are not equal. So -2 is extraneous. It does not work. The last example we're going to look at is where you have two different radicals. And when you have this type of situation, you actually have to square your problem twice. And I'll show you how to go about doing that. The first thing you want to do is isolate one of the radicals. So right now I have two of my radicals on the same side. I'm going to move one of those over to the other side so that one of the radicals is isolated. And in this case, that's going to be the x plus 9, the square root of that. So I have the square root of x plus 9 is equal to the square root of 2x plus 3. Now I'm going to square both sides. Notice I do have a binomial on the right, so I'm going to have to FOIL that or use my shortcut rule. And when you do the right hand, when you do that exponent with the 2, you're actually still going to have a square root in your problem, and that's normal. That happens almost all the time with these. So when I expand this binomial squared, you can use what we did back in 3-3. I do square the first term, so the square root of 2x quantity squared is going to become 2x. Then I multiply the first and last terms together and then times 2. So that's going to be plus 6 square root of 2x. And then I square the last term, so that's going to give me a 9. You can actually write out the FOIL if you want to, but it should simplify to the same thing that we have here. Once you've done this, now you want to re-isolate the square root that remains. So I'm going to subtract the 2x and subtract the 9. Well, in this case, the 9s are going to subtract out and they're gone. If there is a number multiplied by the radical, you can divide to get rid of that. But if dividing is going to cause you to have fractions in your answer, I suggest holding off and just squaring that number whenever you do your square and the square root. So to get rid of the square root, I am going to square both sides. Notice I put the entire left side and the entire right side in parentheses because I am squaring the negative on the left with the x, so that's going to become x squared. On the right, I have to square the 6, so that's going to become a 36. When I square the square root, I'm just left with what's inside, which is 2x. Remember, you are allowed to distribute squares as long as the operations are multiplication and division. In the second line, we couldn't distribute the square because I had that addition there. So we simplify, we have x squared equals 72x. I'm going to continue this over here. Get everything on one side so I can factor and solve. They have a common factor of x, so when I factor that out, I'm left with x minus 72. So I get x equals 0 and x equals 72. Well, if you glance up at your original problem, if you plug in 0, you get 0 plus 9, which is 9. The square root is 3. 2 times 0 is 0. So that square root is 0. 3 minus 0 is 3. So 0 does work. If you plug in the 72, 72 plus 9 is 81. That square root is 9. 2 times 72 is 144. That square root is 12. 9 minus 12 gives us negative 3, not positive 3. So 72 is extraneous. So 72 is not our solution. Our only solution here is 0. There is a concept summary on page 269 in your textbook if you want to go in and take a look at how to do some of the questions that we've done. If you need a summary of what we just went over, go back through, rewatch this video, rewatch the first video, and reach out to me if you have any questions on solving radical equations.